Hello, everyone. Thank you. Thank you. My name is Ariel Kelman. I'm responsible for marketing at AWS, and I want to thank all of you for joining. And I also want to thank those of you on the live stream today. We're broadcasting live from the AWS Startup Loft in San Francisco. And today's event is all about IoT. It's something that we're very excited about AWS. Tons of our customers are very excited about across a wide range of industries, manufacturing, industrial, consumer products. And today we have some product announcements. And you're also going to hear from some of our customers and partners and how they're using AWS IoT services. So without further ado, I'm going to kick things off with Dirk, who runs our IoT business.
Thank you, Aaron. Thank you so much.
Thanks, Dirk.
Good morning, ladies and gentlemen. And it's a pleasure to be here at the AWS Loft in San Francisco. And as Ariel was saying, there's so much buzz and momentum around IoT. And today I wanted to talk to you about a very exciting new services we are working on, which is called AWS Greengrass. And for AWS Greengrass, it's all about devices, connected devices to be more specific, and a lot of them. And you could argue that, of course, connected devices are the first natural constituents of IoT. On these connected devices create an almost insane amount of data. And the smaller the devices are and the more constrained these devices are, the more they benefit from the elasticity that the cloud provides, which is for us the second constituent of IoT. And why do these devices benefit from the cloud? Because device data gets so much more valuable if it is processed together with other additional data in the cloud, especially if you use the information that you generate out of that in order to take intelligent actions, which we call the third constituents of IoT. And when you look at these three elements, first, the things that sense and act and create all of this amount of data. The cloud in the middle, where you can now store and compute on top of the data in order to generate the insights, take business logic and apply it in order to take intelligent actions. You could argue that the abbreviation IoT might be better repurposed where the I stands for the intelligence or for the orchestration of the cloud of the amount of things in the world. And in order for our customers to take now benefit and participate in this intelligence via cloud orchestration out of the things, we created a service with the very same name called AWS IoT. And this service or platform has four major elements for our customers. First, it allowed our customers to securely connect their devices to the AWS cloud and also amongst each other at a very scalable number. Secondly, it allows our customers to route processes and act on top of the data that these devices generate. And third, it allows our customers to create applications which interact with their devices even if they're offline. And for that, we created technology like the device shadow, which you can see indicated via this shadow device in the cloud, so that you have the means as a software developer to talk to a physical device even if it's offline. And fourth, and last but not least, AWS IoT integrates with the rest of AWS services so that you can create this intelligence, whether you use databases or analytics like, for example, Kinesis, or more advanced technology like in the AI space, like Amazon Machine Learning, or more recently, recognition. There are, however, quite many scenarios where there is value if you process the data directly where it's generated. And that might be so because you either cannot, or you cannot afford to, or you're not allowed to upload all of the data into the cloud. And here at AWS, we like to refer to these general principles as laws, because we believe that even the advancement of technology will not change the fact that you have the laws of physics, because the speed of light is only as fast. And think about security-relevant applications, for example, in a factory, where you want to have a secure stop and you want the robot to instantaneously stop, or the conveyor belt, because potentially otherwise it might have catastrophic outcome. Or think about a mining site or an oil rig, which is far away and where you have intermittent connectivity, where you simply cannot even use connectivity there for uploading data. Or the second law, the law of economics. There is, and we talked about this already in the beginning, a lot of data created. And the amount at which data is created is actually much more fast-paced than the shrinkage in cost of bandwidth and communication. So imagine we have one of our customers who is manufacturing, creating modern jet engines. One single modern jet engine today creates up to 4 terabytes of data per hour. You have 4 of them on a plane. You have a standard plane flight. We talk about 50, easily 100 terabytes of data you want to ingest after every flight. It just ain't going to happen. It's too expensive if you at all can do that. And last but not least, we also have the law of the land, which is actually the real law. Here we talk about privacy, we talk about regulation, and all the other impediments that you can have in certain industries. For example, in healthcare, think about it, some of the data, patient-relevant data, you're not allowed to send over the net. A hospital has to store the data for years, even though they could put it into the cloud. Or think about governments, which put certain data sovereign principles on where data can be stored or processed. So, therefore, at AWS, we thought, how can we now help our customers to take benefit of processing data at the source at the exact same way and easiness like AWS IoT allows them to do that in the cloud? So what we wanted to build a service that take local action based on the data generated locally, that then on top also can allow local devices to communicate securely with each other, and also sync state and data when all of these devices are not connected to the cloud, so that it simply works. And whenever the connectivity comes back online, that the entire systems automatically synchronize data and state with the cloud. And we designed to work it so that the software and service can run on literally any device which is powered by a general purpose CPU running Ubuntu or Amazon Linux, which is powered by x86 or ARM-based architecture. And we came down to 3 simple figures. We said, okay, if you have 1 core, 1 gigahertz, and 128 megabyte of RAM, you could, in principle, run AWS Greengrass, which makes it accessible to all standard gateways, programmable logic controllers, or even as cheap as $10 devices like a Raspberry Pi. Therefore, welcome to AWS Greengrass, a service which extends AWS and AWS IoT onto your devices so that they can locally act on the data that they generate, still taking advantage of the cloud. And AWS Greengrass take advantage of the resources and capabilities of your devices locally and extend them with the cloud for management, updating, and elasticity in compute and storage. And how does it do so? By providing 4 essential features. First, it provides your local actions by bringing AWS Lambda to the edge, where you can execute code in the beginning written in Python 2.7, and these Lambda functions then are deployed from the cloud onto your devices. Secondly, it provides local trigger or messaging between these functions and the peripherals of the device which runs the Greengrass core. But it also allows messaging between peripheral devices and the Greengrass core and these peripheral devices on a local network that run and use the AWS IoT Device SDK. It also provides you data and state sync. This is important because these trigger-based action model that we use in the distributed compute architecture of IoT is stateless, so you need state synchronization. And also this device scheduler that we now bring locally on the devices, whenever cloud connectivity is reestablished, automatically syncs the data and the state of all of your devices with the cloud. And last but not least, it does so securely using the exact same security mechanisms that you're used to when you use AWS and AWS IoT. Namely, it uses and mandates mutual authentication for all the devices locally, and it ensures encryption of all of the data at any given point in time by acting like a local certificate authority for what we call a Greengrass group. That is AWS Greengrass from a feature perspective. So, and what benefit does it have for our customers? We already talked about the first one, responding very quickly to local events in near real time, simply because you can take actions wherever the data is sensed on a device. Secondly, operating offline. once you deployed your Lambda functions locally to your device groups and you have all the pops up and subscription done, the local devices can interact between each other, the messages are routed, the actions are taken, the states is preserved even if you're offline, and whenever the system gets online again, connecting to the cloud, it automatically syncs. The third benefit of this is that it has a simplified device programming. If you come like me from the embedded world, you know how painful it is when you have local embedded resources that you have to optimize. And now with a Lambda function, you can literally write the code in the cloud, debug and test it in the cloud, and then deploy it on a local device, making embedded programming accessible to a much broader audience of programmers. And then, of course, with these elements, you can reduce the cost of your applications. Be it because you now have the freedom to decide and locally process your data and only send those elements of it or the aggregation of data to the cloud which you deem important to your business. And secondly, it also allows you complete new use cases. In the past, what if you hadn't had connectivity? You simply get rid of the data. So much data was lost. And now you can store it and aggregate it locally so it's not only cheaper, but also more valuable. And I already talked about the last one, and I cannot stop emphasizing the importance of the security in IoT. Again, at any given point in time of data creation, data handling, and processing, we make sure that it's mandated via mutual authentication and encryption. So Greengrass. I already talked about some of the use cases, but it is for many of them. It's not mining I mentioned. I mentioned some electronics and manufacturing, but we have customers also in the financial domain, in IT, healthcare, agriculture, communication, you name it. And the interesting part here, of course, is now that AWS Greengrass makes it much more easy for our customers to build and utilize the resources, what their devices provide in consultation with the cloud. So it gives you the tools that you can have distributed compute infrastructure working in consultation, doing the local execution, and decide which of the data you want to put in the cloud whenever you're online or offline. So that are the use cases of AWS Greengrass. And since AWS Greengrass, the service and software runs on your own devices, we also build a rich ecosystem. Because devices are powered by chips, so we work with the leading chipset manufacturers, which then put those chips into devices, and the device manufacturers and OEM, and we also have some of them here today. And then, of course, on top of these devices, you need to run operating systems. So we work with operating system companies like Canonical and their Ubuntu Linux distribution. Then we work with wireless operators and connectivity companies because you want to have the data also getting to the cloud whenever you can do so, and we work with ISVs, technology providers, and consultants which help our customers to then build their application. And when you think about it, in the past, manufacturers had to take a choice. Do I either build a system which only works locally, which is almost real time and permanently available, or do I take the benefit and the ease of use and the elasticity of the cloud? And today, you don't have to do this trade-off anymore. With AWS Greengrass, AWS, and AWS IoT, you can have the best of both worlds combined. And I'm very proud today to show you, if my clicker works, our launch customers and partners, with whom we worked very intensely over the past few months. So since we announced AWS Greengrass at reInvent 2016, we were working with our partners to make that a reality. And today you will see some of our partners also here on stage on their journey with Greengrass. Some of them already have today technology and products which you can use right after the session. Others are about to go into production. And one of the partners even managed to get operational significant value out of Greengrass in as short as a 2 weeks time frame. And I thought, why not start with this model? Why not explain what happened? Let me introduce to you Rio Tinto. And for those who don't know, Rio Tinto is one of the leading mining companies in the world. And what you see here on the photo is a mine site of Rio Tinto, and the tiny little truck which is going down the road is in reality humongous. These are beasts of machines. I mean, they have the size of 3, almost 4-story buildings. And the tires on the truck, I mean, I'm not tall, but if you take me in my hands and double me doesn't suffice for the size of a tire. And they have typically 8 to 10 of those tires on the truck, and one of these tires costs as much as $100,000. And then you can imagine this machine is pretty heavy. And then what shows like small little roads, typically there are 2, sometimes even 3 mileage of road just because the mines are so huge to get the equipment down into the mine. And you can now think about when there is road roughness, that there is an enormous amount of wear and tear. One of these tires just explodes, the wall just gets broken, or the entire truck gets a problem. It's about a lot of money, and also the entire value chain gets broken. And till now, how Rio was solving this, they every now and then sporadically set teams down to check the road roughness. And road roughness doesn't mean a small pothole. Again, a hole is potentially the size of a single family house. So they had to figure out where are those and grade the streets, or the whatever you would call the path down into the mine, or whenever a truck driver figured out something and remembered and then called the dispatcher. And they said, what if we could more or less online map what is the roughness of our road? How can we do this retrofitting our devices so that really we solve that problem? And that's what they did. They went into one of their mining sites called the Boron mining site, and together with Intel, they equipped and retrofitted their existing big haul trucks and put a tiny little device on the truck, so that it was a one-touch exercise which did nothing else but sensing vibration. And it sensed at 100 hertz, means 100 times a second there was a sensing of vibration. And then they used Greengrass to aggregate these vibration measurements to come up with a roughness measure. And on top they had, even in the mine, then GPS, and they were combining the location with the roughness measure. And then they could use Greengrass from the console and optimize the algorithmic, okay, is it now really rough, and is it the right thing? And then they wanted to send all of the data to the cloud for aggregation. And of course, in the mine, very intermittent connectivity, so they were able then to use Greengrass to buffer, and whenever there was small little spots of connectivity, sending it back, and they were able to create those heat maps where green means smooth or okayish type of roads, and red means, oh, pretty rough, you better don't route our trucks around here. And the best thing of this was that was then made available to their mobile operators and their control centers, and it all worked from the first moment where they started fitting out this pilot, touching the first truck until it gets into operation. It took 2 weeks. And the best thing about that story, at least for me personally, was when the representative of Rio Tinto explained that to us, said that the engineers in the mine, when they saw this, first thought, that's not true. They thought that needs to be some type of, you're just fooling us, April Fools. Because they said, in the past, whenever we had to do something in our equipment, it took literally months because we had to go all the time back, we had to optimize it, we had to go to all of the trucks. And here, you touched it once, and because you can control and update at any given point in time via the cloud, it was just happening in 2 weeks, and now it's operational. And with that, I think you have seen enough of me. And like always at Amazon and AWS, we do this mainly for our customers and for our partners. I'm very happy that we have quite a bunch of our launch customers and partners here today, which will come on stage and give their story how AWS Greengrass helped them. And I'm very happy to invite first Hamid from Stanley Black & Decker on stage, who is the Director of Software Engineering for the Digital Accelerator Group. He can tell us and you how they use AWS Greengrass. Hamid.
Thank you very much.
Thank you very much.
Thank you very much, Dirk. My name is Hamid Montazeri, and I'm the Director of Software Engineering for the Digital Accelerator part of Stanley Black & Decker. Stanley Black & Decker creates tools, devices that are used for manufacturing and construction business activities throughout the world. The Digital Accelerator, my group, was created 2 years ago to bring more IoT to our offerings and help our customers in that way more. At the Digital Accelerator, we look at 2 types of problems in general. On one hand, we look at IoT enabling individual devices. IoT enabling a tool is an example of this category. On the other hand, we look at making digital workspaces for environments that traditionally had challenges with connectivity. bringing IoT to environments such as manufacturing and construction, where connectivity is a challenge, is another example of this category. For both categories, we look at 4 characteristics in order to design our IoT solutions: observability, controllability, optimality, and finally, human interface. For the observability part, usually you find sensors that you can install and gather data and analyze in order to obtain customer insight, engineering insight, or predictive maintenance insight. As the number of sensors have gone up, of course, there has been an explosion in data, and there is a cost in storing data. With a tool like Greengrass, as an edge solution, we are now able to apply filters that would judiciously reduce the data set to the appropriate one that we can store, helping us reducing our storage costs. On the controllability side, a lot of the dynamical systems, based on the observations gathered, would compute either based on a theoretical control system algorithm or machine learning or artificial intelligence, a set of control inputs to control the system. A thing that is important here to note is that control systems are very, very sensitive to delays, the type of delays that Dirk talked about, based on laws of physics. In fact, you can make a control system, a dynamical system, destabilized based on delay in your system. As a result, having an edge solution, such as Greengrass, is really critical for some of the projects that we work on. Optimality is a very important factor in creating IoT systems. A lot of times, we are looking at optimizing several characteristics. Costs are always one, engineering performance is another one, and there are other things that we can mention. The combination of optimality, observability, and controllability is what makes a human interface creation much easier and helps the system to be controlled by humans much better. With an edge solution such as Greengrass, we're now able to do that much more efficiently. We started our journey with AWS about 2 years ago, essentially as soon as AWS IoT system came out. As we moved through our projects, we discovered that there are a large number of projects that required an edge solution. With Greengrass, we are now equipped with the right tool to attack those problems and create better products for our customers. Thank you.
Thank you so much, Hamid.
Thank you.
Awesome. Thank you very much. And now I would like to welcome Sash from Intel, the general manager for their IoT solution providers. Sash,
thanks,
it's all
Dirk.
yours.
Thank you for this fantastic opportunity to be here with you and talk about Intel and AWS Greengrass collaboration. We're really excited about our joint collaboration with customers such as Rio Tinto. Dirk, in your earlier presentation, you mentioned about Intel's participation in the joint pilot, where we instrumented the earth-moving equipment and trucks with sensors and gateways running Greengrass and running analytics on the data that is collected and driving business outcomes like extending the lifetime value of these high-value assets. Really excited about that. So I'm going to talk about, firstly, Intel's IoT vision. We see this IoT vision to be in 3 phases. First, connect the unconnected. So this is basically the legacy equipment that collects the sensor data and then ships it back to the cloud. The second one is smart and connected things. So here you have a little bit of more edge intelligence. You're able to not just process the data locally, run analytics and make decisions, but you're also able to communicate to the cloud. The third phase is autonomous devices. So here, these devices are truly intelligent. They're able to communicate with each other and also to the cloud and make autonomous decisions. We are focused on various verticals: healthcare, industrial, energy, utilities, transportation, autonomous driving, and so on. Greengrass is very relevant for Intel, mainly because it helps us in the transition to smart and connected things and autonomous devices, and is very complementary to our vision. In August of 2016, we announced at Intel Developer Forum, we announced the availability of a joint reference architecture. Today, on this architecture, we have deployed many solutions. Today, we are announcing the availability of a joint reference architecture that incorporates Greengrass, which means that you have Intel devices running Greengrass and able to do intelligent things like running edge analytics and making local decisions, ability to store local data, and so on. This is great. I mean, architecture is great. But how does it really come to life? Today, we are announcing the availability of IoT Enterprise Development Kit that comes with a gateway. It comes with a sensor box that's the green box over there, with sensor modules, development board, the starter kit, and Greengrass plugins, as well as the IDE that supports various programming languages, the documentation, and code samples. This is really good for developers to do rapid development and application and prototyping. But what about commercial deployment? So we are announcing today the availability of a number of commercially hardened Greengrass-enabled gateways. This is coming from our ecosystem of equipment maker partners. And we are working with our ecosystem to deliver solutions and drive business outcomes. Another thing, how does this all come together? A combination of the joint reference architecture that supports Greengrass and the enterprise IoT development kits, as well as the commercially hardened industrial-grade gateways, we can create end-to-end IoT solutions that can be delivered on a platform that is commercial grade, it is scalable, it is flexible, and it is deployment grade. It makes the deployment very easy. It delivers a plug-and-play experience for developers, which means that you just power one of these devices with all the sensors connected. Boom, you see the data land on the platform, ready for developers to start developing these applications. And the time to market is very, very quick. In summary, we are announcing the IoT Dev Kit. We are announcing the Greengrass-compatible gateways. We are announcing the Greengrass-enabled joint reference architecture. With the combination of this through our ecosystem, we are driving business outcomes. Some of the examples, we are working with customers, vertical use cases such as connected mine, connected port, smart home energy monitoring, and home safety. With the strong collaboration with Amazon and our ecosystem, we are very excited about the breadth of upcoming opportunities. Thank you very much.
Thank you, Sash. Thank you, my friend. Thank you so much. And now it's time to also have some of the equipment manufacturers then coming on top. So it's my pleasure to invite Gary, who is the SVP Connected Home from Technicolor, one of the leading, if not the world-leading gateway manufacturers in the home.
Yeah,
thank you, Gary.
Thanks, Derek. Thanks for having us today. That's right, I'm here from Technicolor. We're in the media and entertainment industry, and specifically I come to you today from the Connected Home Business Division, which supplies broadband gateways and set-top boxes to network service providers all around the world at huge scale. We ship millions and millions of broadband gateways and set-top boxes each year. It's very likely that you in your home, from your network service provider, whether broadband, whether video, voice, have a device in your home that came from Technicolor. When we talk about smart home and IoT and where we are today, this is what we've kind of come to this reflection, this observation. We haven't yet delivered really on the full value of the smart home proposition. From a consumer point of view, it's oftentimes involving too complex of a user journey, difficult use, devices that don't just naturally talk to each other, and always some concerns about data security and privacy that Dirk alluded to earlier, as well as the costs associated with these kinds of services that might have been offered to the general public from a network service provider so far. And for our customers, our direct customers, the network service providers, it also hasn't been a universal success from their point of view. Oftentimes very complex business cases that they have to put together in order to launch a new service, lack of standards and interoperability. Again, concerns about data security and privacy that we've all spoken about, integration with third-party devices, and the cost of transport of data to the cloud. So this is the observation of where we are in the industry Technicolor at this point in time in 2017. But what is it that we believe? So we believe that the best is yet to come, and that the realization of the smart home and the services and applications associated will come to fruition. And for our business, we're going to move from the left-hand side of this slide to the right-hand side, which means we're going to move away from a world where devices were designed to optimize cost and do the right amount of functionality at the moment it was envisioned to be deployed in the field, and hopefully it could make it for a fair number of years, to something that we see more on the right-hand side, which is a more open device, a more capable device, if you will, a playground upon which applications and services can be added along that device's lifetime being spent in the field in our homes. And this is our belief at Technicolor. This is what we believe the next wave is for our types of devices. So what are we doing about it? What we're doing about it is, first, we discovered ourselves together with AWS with a shared vision in this space. And so we are integrating the Greengrass environment into our devices to bring that edge compute capability to our devices, and all those same cloud tools available now at the edge, which of course opens up the massive community of AWS developers to be able to dream about, think about, deliver new applications and services that could be positioned at the broadband gateway at the edge of the network in the home, whether they be doing that for us, for our own services and applications that we would like to offer to our customers, for our network service provider customers themselves, or for other verticals that may be welcomed into the space. Also at Technicolor, we're doing a fair amount of work to also create a nice secure sandbox for our playground for these devices, making sure that we take care of containerization and these kind of things, because of course our network service providers, first and foremost, do not want that service to go down. So we're taking all the measures we need to in the devices to make sure that the core services that we're used to will be delivered in continuous delivery and not interrupted by the new applications and services, but still have that open playground where we want to welcome those new apps and services. And a little bit, from our perspective at this moment, the cherry on the cake is through our partnership with the AWS IoT team and the Greengrass team. They've also introduced us to the Alexa Voice Services team at Amazon, and we have devices now that are also bringing that's all familiar or becoming familiar voice interaction with your device for out-of-the-box setup and for troubleshooting along the way. And many of us that have been using Echo and devices like that recently understand the power that can bring, especially for, again, our network service provider customers who are looking to reduce truck rolls and the amount of touching and visits that they have to make to the home. So if we can have an out-of-the-box experience that's voice interactive for easy setup, that just makes things all the better. Lastly, and again, this is thanks to the partnership with AWS and the IoT team and the Greengrass team, is we're taking benefit of other verticals in the space. And this means two things for us. First, it means that we have the opportunity now to sell devices to new customers, so to participate into industries and the verticals that we have not historically sold to. And we've been working very closely with AWS to make some of those connections, and we're very excited. We're already engaged on a couple of those. As well, we hope to be able to bring other verticals, applications, and services into our space, which is the network service provider space, so that whether it's healthcare or other verticals like that, can one day dream of taking advantage of this device that we are every day and in millions of quantities putting at the edge of the network into the home. Thank you.
Thank you, Gary. Thank you so much. And now let me welcome Jeffrey Torrance, Vice President, Business Development from Qualcomm.
Thank you, Dirk. Good morning. At Qualcomm, we see tremendous traction with customers for edge processing. We see specific examples of that in An example of that would be a gateway that you use for controlling the distribution and routing of inventory on a delivery truck. So effectively, you have a device that's connected to the cloud using cellular. It uses Bluetooth low energy to keep a track of the inventory and GPS to determine the location. And, oh, sorry. And this hub is able to advise the driver what inventory to offload and onload and to manage the route. Obviously, you get a situation where you have no cellular coverage, and the magic of the gateway is that it has a cache, so it can continue to guide the driver and audit what's happening, and when you come back into coverage, is able to sort of synchronize the cache again. Another example of what our customers are doing is building video analytics into the edge. So effectively, you have a camera and you have a video stream, and that can go to the cloud to identify features and events and then trigger some action. But feeding that data up into the cloud is very, very costly. So the customers push that processing down onto the edge. The additional benefit of doing that is the data that is fed back to the cloud then is much more abstract, because you're sending back hashed messages rather than a continuous video stream. So what we're seeing is significant traction in terms of the number of engagements we have with edge processing, and we're seeing at the same time more intelligence being pushed to the edge. And to enable those things to happen, we provide a family of chips at a very low power consumption, high level of integration that have 3 principal areas of functionality: security, computing, and connectivity. What the security allows you to do is effectively the chip has an immutable ID on it, and you can serve some keys which allow you to update the firmware with a high level of security. Those keys can also be served into applications. So your applications you deliver on those chips, you can serve your own keys, and to your customer you can serve keys in a very secure way to develop applications and serve keys to applications developed on your platform. Our chip is designed with a very heterogeneous approach to computing, which means that you can take advantage of different fabrics within the chip to service different sorts of functionality. So specifically, we have a DSP, so we have a tremendous amount of number crunching you need to do, and want to reduce the power consumption or do that very efficiently. You can do that on the DSP entity. We have a collection of ARM microcontrollers or microprocessors on chip, which enable you to get very good code density and allow you to deploy third-party software. And we have a GPU, which allows rendering of graphics historically. But in these IoT edge processing applications, we increasingly see that GPU is being used for machine learning at the edge. And then, of course, we're Qualcomm. We have a tremendous suite of connectivity. We can enable you to build 3G and 4G and a roadmap to 5G. We have the alphabet soup of Wi-Fi solutions. We have the low-power technologies, Bluetooth, Bluetooth low energy, NFC, RFID, and in the same bucket, the radio-based location technology. So it's great, a lot of growth in the number of applications, a lot of growth in pushing smarts to the edge. We think this highly integrated low-power computing platform is ideal for deploying these applications. What's special today? What's special today is we've spent the last few months porting AWS Greengrass onto these platforms. So all the benefits you've heard about before, about being able to get to market quickly, to be able to shift code seamlessly from cloud to edge. And fundamentally, from our point of view, we see AWS Greengrass as a tremendous catalyst to help defragment the Internet of Things. And that's the way we can grow the opportunity to create products and services and give all the goodness to global GDP that's promised from IoT. So what does this mean for you guys? This is the Dragon Board 410C. This is a device where we have pre-integrated and tested AWS Greengrass. All the details to get the board today, to get the software today, are available at developer.qualcomm.com. So this is based on the APQ 8016 silicon. And a customer, Thundercom, has taken that silicon, put the video analytics in an end product, and also included hub technology to allow peripherals to connect to it. So to wrap up, we see tremendous growth in this space. We think we've got a great chipset, wonderful partnership with, which we're super excited about with AWS. And then the products are available on the internet today. Please go to developer.qualcomm.com and start playing with this stuff. Many thanks.
Thank you, Captain. Good. Thank you, sir.
Oh, sorry.
Cameras. I need one of those cameras. And we talked so much about connectivity, and we thought, why not have an expert on connectivity on stage? And it's really my pleasure to welcome Torsten, who is the Vice President of Advanced Mobile Network Solutions from Nokia. Torsten, it's all yours.
The Internet of Things is developing fast, helping industry to automate operations and become more efficient. To achieve this, IoT connectivity must be optimized and reliable. More and more sensors and devices trigger data traffic to and from the cloud. For some very interactive applications to be successful, however, there is no alternative to having these round trips of data with extremely low latency. In addition, enterprise IoT data must be kept private, requiring robust, resilient, and secure connectivity for business-critical communications. A key technology in this digital transformation is edge computing. Today, we are creating an architecture that is a forerunner of 5G, with industrial IoT being one of the main uses. Our solution enables enterprises to embrace digital transformation today to achieve greater agility and efficiency and rapidly deploy new services.
Wow. What a moment here. And it's really exciting to be on stage together with the Amazon Greengrass team and everything on the partner ecosystem, what we developed here. So my name is Torsten Rohrbrecht. I'm running in Nokia a unit which we are calling not AWS, it's AMS. We call it Mobility Solutions, Advanced Mobility Solutions, where we are taking care from providing under the kind of classical type of connectivity service provider into the digital industry of the enterprises, the private LTEs, the public LTEs, and then ultimately into the kind of edge computing and then the connectivity solution into the 5G. So IoT is part of my business, some other parts like public safety, and a lot of all the mining and the other domains which we talked already around it. It's not a coincidence that also Rio Tinto is a big customer of ours, and we've done a lot of projects together on these domains because this is really crucial for this type of industry, like Dirk already mentioned, which really makes a key impact for them and a key value for them to really drive this forward. And also on our end, we've been working a lot already in these networks of today, which are all based on LTE technology, on the edge computing capability in order to reduce latencies. So it was more than natural that we were starting to work very closely with the Amazon AWS team on already a lot of common customer cases. And now on the Greengrass, where this kind of both cases really come very properly and nicely together, which allows on our architecture of the mobile connectivity side to really run now all the AWS Greengrass as a client on this one, connecting it even to the intelligence of the network, which tells you exactly right how many people where moving and what kind of load of the network is on top of the kind of intelligence which comes from the cloud out of the type of AWS Greengrass domain there. So there are these type of products which we've been developing over the last year, and I'm pretty proud that on the Nokia side we've been a front runner on this type of edge computing capability. Some of us knowing me from the history on the Mobile World Congress 2013 already. We've been launching products which we called at that time liquid application and type of edge computing capabilities. Today we have shrunk this into these type of small boxes which you see all over, deployed already in millions, which have got an open interface already today for compute and storage capability, which allows to distribute the cloud basically now dynamically into the existing infrastructure as it exists today into US and in some other countries, and make use immediately of the Greengrass activities around this. So these cases which we have running right now already were a little bit of, let's say, subscale or early in the industry. And I've had a lot of troubles also on my board, I can tell you, of justifying all the investments, saying the cloud goes into the edge, it's need to be there, 5G will be exactly going into this direction, and here we are. And finally, I'm very happy to have this type of big players, big industries like Amazonis on the cloud, really joining us from the telco industry, from the IT industry, to bring this now so nicely together that suddenly we see also clear and obvious that the edge computing really makes a difference and really makes a kind of key essence of this one. Let me just show two example cases, what we have there. One of them is on, and Dirk mentioned it, on the oil rig kind of example. So this is a typical type of very simplified picture on the oil rig domain. You've got a very far remote area. Connectivity is not for granted. It's a very difficult area. We go over satellite to really connect the people and the machines there. We go sometimes through microwave radios, very little over sea cables, which we also do, but seldomly. And then it's also limited, and it started with all connectivity of the people there, of having the basic connectivity. When the machines get connected into this one, it all became not sufficient. And even though we were using already at that point some AWS services from the cloud and connecting it back, as it was interrupted, the connectivity didn't work properly from the round-trip times. Then we started to distribute inside the oil rigs the kind of what we called MAC, mobile edge or multi-access edge computing capability, which used at first as a buffer type of capability, caching capability, to ensure local connectivity without really cloud distribution capability into the local environment, which served us very well over the last years to serve this industry and to develop a nice business on this one. Now, when we can put the kind of AWS Greengrass on top of this architecture, it opens up so much more capabilities. And now we're getting immediately into the full service of the cloud, even though you've got some kind of challenges in this kind of area when you go in these very far remote domains there. So at the end, we developed this type of architecture, how for us is a blueprint, which is 100% aligned and worked very closely together with the Amazon team on how we get into this full end-to-end solution. And it's not only about cloud connectivity, as you can imagine, it's a lot about local breakout capabilities, about really, let's say, having on the first the kind of data flow done, but also for sure at the same time we offer also all the basic connectivity services which everybody of us expects from the kind of LTE domain really running there. So it's really a full combination of the IT, cloud, and the telco-grade standard type of telco area on this one. At the end, it boils down to three key main pillars, which the AWS Greengrass really brings us now on this one. It's a low latency, and low latency being very, very key on examples like what we are running, for instance, on highways, the kind of connected car. Right? If you have more than 10 millisecond round-trip time, it doesn't work. And 10 milliseconds is already an eternity in this domain. In 5G, we want to bring it down into 1 millisecond, and our Nokia Bell Labs activity is working very hard on the moment on bringing it further. But today, and over the next years, this architecture is really the only one enabling this type of low latencies in this environment. And secondly, as Dirk also mentioned, security, privacy is the key aspect, depending on legislation in different countries, but also on depending on sensitivity of the different industries. Not a lot of companies, when they create their private networks, want to really share it all over in the cloud. Some of them are very suspicious. They want to get a hold on this. They want to have it local, and then just use selectively the cloud services on this one. Here, exactly, Greengrass is 100% solving this need and answering this domain. And then last but not least, cost saving, like I mentioned, on these oil rig environments, right? It's very, very costly for them through going over the satellite link. Luckily, the satellite link lately are paid by the megabit, so it's not by the connectivity, just by time. So here, the cost saving was big, but now already we can cache a lot, compress a lot, and can use really the advantage of the Greengrass to really bring further down the cost by the factor of half. We've got all of these running in our laboratory environments. So in Dallas, Plano, I invite all of you to join me there and to have it running. We have got the first customer cases, which we now develop further on, and I'm looking forward to really make a history and impact to really open up the IoT industry together with the partners and the Amazon team. Thank you.
Thank you, Thorsten. Thank you so much. And last but not least, I would like to welcome Tilman, Director of Engineering for BCG Digital Ventures, to tell us a little bit more about what they do with their partners and customers. And I have to shake his left hand because Torsten came here, or Tilman came here, despite being almost fatally injured. So
thank you. Thank you, Dirk. And at first, thank you, Amazon and AWS for inviting us. And let me say, on behalf of BCG Digital Ventures, we are really thrilled to join this event and to explore with you guys the edges of technology. I think today morning we have heard a great lineup of examples how to leverage edge technology across the industry. And I would like to share with you one last example from the manufacturing industry. So in the manufacturing industry, from a technology point of view, maybe there are two processes of interest. One is the product design process, and one is the manufacturing process. I think in the product process, the industry has done a great progress in the last decade. So thanks to the data backbone and the developing of PLM solutions, I think it's getting much easier to exchange data across the different applications in the product design value chain. And also in the manufacturing process, if you think to MES solutions or MOM solutions, when it's up to aggregate data, we also done some progress. But what we also see is that the automation pyramid, when it comes to the automation pyramid and the NCs and PLCs, I think they are not future ready by handling the increasing amount of data, especially in real time. And even if you see the existing IoT platforms, they only offer a one-way communication from the shop floor to the cloud. So why is this a problem? I would like to give you a concrete example. Think of, for example, you would gather a lot of information on your shop floor, and you would send these data into the cloud, maybe to build up a prediction model. And now you came up with an insight, you see one anomaly. Let's assume, for example, you would need to adjust the acceleration curve of conveyor belts in your production. So what do you do today? Today, at first, you need to stop production, which is a bad thing. Then you need to identify the right person in your company to fix this problem. So you need to go down to the brownfield and work on this on a PLC level. And afterwards, you need to re-ramp up the production, which is a challenge by itself. So think of a perfect world. In a perfect world, think of a fully connected and integrated world. You would maybe gather also information, maybe as many information as you want. You do not need to care about how to synchronize these data between your edge device and the cloud. And you can maybe unlock the machine learning capabilities from the cloud for the shop floor. Maybe you can even correlate your data with external data. And maybe you also have a kind of a digital twin, so a digital representation of your actual product, which you can leverage. Once you created an insight, you can derive an action which can take immediately effect on the shop floor. What I'm telling you here is not a vision. It's really turning into reality by leveraging Greengrass technology. And we've done this. And we, as a team of around about 20 software engineers, and let me reference at first the Amazon Industrial Software Segment Group headed by Joseph. So thank you, Joseph and team. Also, I would like to reference, as you see here, the Laboratory for Machine Tools and Production Engineering at Aachen Technical University. We built up in 8 weeks, by leveraging Greengrass, a real industrial use case by connecting or controlling 2 KUKA robots in real time with an edge device. But we've done more. We also measured the energy consumption of these robots. We correlated this data, sent these data into the cloud, then correlated this data with the actual energy price, built up a production or prediction model by leveraging IoT, AWS IoT functionalities, build up this production model, and thanks to the device shadow or the digital twin, we would be able to take immediately action on the insights which we generated. And now I would love to show you this here real on stage, but unfortunately these 2 robots, they do not fit into the elevator. But we have a video prepared for you, which I would like to share with you, so you see that it's not a vision, it's turning really into reality, and we call this edge-powered industrial control. Thank you.
for the first time ever, we show the control of industrial robots in real time with Amazon's Edge technology.
Seamlessly integrated with the cloud. The Edge device is controlling two KUKA Agilus robots passing a workpiece back and forth to each other. In this case, we use Raspberry Pi, but the Edge can run on any low-cost commodity hardware.
This works independently of an internet connection in real time. Furthermore, we can leverage the power of the cloud by doing machine learning, big data, and analytics to optimize the configuration of the shop floor. So in this showcase, two robot arms are passing an object around with the help of a conveyor belt, and they have to detect the object through two light barriers where the object goes through. And how we do this is by leveraging the power of the Greengrass device to calculate the tool center point where the arms have to move. And the new thing about this is that we can, from the cloud, create a Lambda function that gets pushed onto the device and then executes this calculation in real time. Not only that, but also this device has to have a steady heartbeat that is sent to the device, to the robot arms, which proves that this is real-time capability.
Thank you. Wow, this is robot ping pong. How cool is that? Robots playing ping pong in real time. And don't get me wrong, this is really sub-millisecond analysis, because otherwise that wouldn't work. So thanks again, Tillman, for that. And I hope we were able to show you the breadth of use cases that our partners and customers apply AWS Greengrass today, the amount of elements of products which are already available today. But I think the most important message I wanted to give you, this is not fiction. AWS Greengrass is made available today, GA, to the general public, and we'll start, as of today, having AWS Greengrass in 2 of our US regions, in Oregon and in North Virginia, and we are bringing it to Europe, in Frankfurt, and to APAC and Asia Pacific and Sydney over the course of the next few weeks, and after that to all other of the AWS regions. With that, I would invite you to try it out today. You have heard some of the equipment you can actually immediately purchase or download, and if you go to aws.amazon.com/greengrass, go there, try it out, it's real. With that, the only thing which is left for me is to thank first all of the speakers who came there and the companies they represent, the partners and customers. Without you, that wouldn't be happening, and it's not possible. I also would like to thank my own engineering team, represented by Whaley here in the audience. You have a rock star team, Whaley. These guys were working over the last months almost literally day and night to make that work. And last but not least, I would, of course, like to thank the audience here in the room and on the live stream for your patience and for your attention. Thank you very much. And I would again like to invite Ariel on the scene so that we can start getting your questions. Ariel.
Thank you. Oh, I guess we need this. Yeah, we have time for a few questions. So, and I think we have some mics in the audience. Any questions? Back there.
Can you hear me?
Oh.
Hello?
OK.
Yeah, I've got a question on if there's any plans to put the orchestration, like step functions or the workflow, as part of the Greengrass SDK.
So first of all, of course, Greengrass, in essence, is a programming model. So you can now use Lambda for anything you want. So if the question is, do we have currently concrete plans to put step function as it is in the cloud, putting it down to the device? No. But you can, of course, use step functions in the cloud for your workloads, and you can have similar functionality via Lambda function deployed locally on the device.
Hi, what's the memory footprint of Greengrass? How small can you make it?
And that's what I tried to explain beforehand. The moment we say you have one core, you have 1 gigahertz and a 128 megabyte of RAM available, then you can install the Greengrass runtime. Of course, the real footprint of Greengrass depends heavily on the amount of Lambda code that you execute and how many devices you connect. But typical use cases, we believe the moment you have 128 megabyte of RAM available should be possible.
So that's the smallest you can make it.
That's as today of launch, which you recommend. How far we can go over future, time will tell. We're working hard to putting it even smaller.
Hi. Is there any capability for code signing on the local Lambda functions to make sure that what you put down there stays there and is hopefully maybe encrypted so that anybody looking into that device has no visibility on what you're doing?
So that's a very good question. So first of all, everything we do from a communication perspective is encrypted. So when you deploy a new Lambda function locally down, the Lambda function is sent in an encrypted manner locally to the device. And also the execution is done in a dedicated sandbox with a secure file system. So of course, it's the exact same methodology that we have in the cloud, so that you can then, of course, into the cloud, into your own account, decode and more or less test your Lambda functions, and then we'll take sure that it gets down encrypted to the device, and of course it can only execute on the device according to your certificates and your policies.
Can you talk briefly about what kind of support you're going to build for very low power battery applications, or maybe a device is asleep for most of its life?
So maybe just to be clear, Greengrass is several things. First of all, it gives you the capability of bringing down a runtime environment on a device which we call Greengrass Core capable. That's what the gentleman was asking. So you need to have a device which is at least powerful enough with a CPU where you can install this Greengrass Core. Then small MCU power devices, which are typically sleeping all the time, and every now and then wake up, which are too small, which have typically kilobyte of RAM or have very low compute, they are then not excluded as long as they can handle the IoT device SDK. And what they need to be able to handle is they need to be handling certificates, like, for example, an X509 certificate, because otherwise you cannot mutually authenticate them. And we also mandate the capabilities of encryption, like something like TLS 1.2. But that we provide via the IoT SDKs, and here we talk about kilobytes. And we make this available in 8 languages, for example, in C or C++. So you can then integrate this onto your embedded operating system or even your DSP code. And as long as the device has capabilities of 128-bit encryption and can handle certificates, then it's part of what we call a Greengrass group, because the Greengrass messaging is then controlled by the core, and you don't need the connectivity to the cloud.
Yeah, is there any plans to put a data store in Greengrass, like DynamoDB or another data store?
That's a very great question. So at the beginning, the way of how we store and sync data is called the device shadow. And of course, underneath the device shadow, you have a sort of database. What we do today, we have a database product, which you can actually see when you look to your right here on the table, which is called the IoT. It's the Snowball Edge in its second version, which is a storage device, which you can, of course, rent from us. And on that new Snowball Edge, we have Greengrass. So if you want a lot of storage, it comes more or less with the S3 buckets placed in. And if you like, you can go back and talk to the gentleman over there who can explain it to you. So today, if there is then additional storage capability just in the Greengrass core, the answer is no. It is the device shadow. You can, of course, use all storage capabilities and file systems that we have locally, access it via Lambda function. And if you need a lot of storage, S3, there is the Snowball Edge. Other questions?
What's the network overhead? Say, sending a kilobyte of data for low bandwidth cases.
So I didn't understand the question.
For low bandwidth cases, say you're sending a kilobyte of data, what's the overall network bandwidth if you're trying to estimate whether you're going over your data limits?
There is no one single answer to this, because it really depends on the amount of messages that you send. I mean, you can go down to extremely low messages, because if you only send a ping message to keep alive, then we talk about 50 bytes something. And then, of course, since we mandate TLS, so what you would need to have, you have to have the overhead for TLS encryption. So that's the absolute minimum that you need. Otherwise, it's ping messages as a minimum. But of course, maximum, you can put as much data as you want.
So a similar question to your data store question. What about elastic cache kind of services to store things in memory? Since Lambda functions are stateless, so you may want to buffer things to do data reduction.
So, and again, our mechanisms for state synchronization is what we call the device shadow. So that means the device shadow is a way where you can store data. We typically use this in a SQL type of JSON format, which you can quote down and you can say what are the different states, what was the last state, what is the desired state. So we don't have inbuilt similar functionality like elastic cache out of the box. You could, of course, implement this locally if you wanted to, but our method of state synchronization is via the device shadow. And again, the device shadow is the exact same methodology which we use in the cloud via AWS IoT. And the benefit of this is if you don't have connectivity and you do local caching, the moment the entire Greengrass group gets online again, you have automatic synchronization and data sync with the cloud. That comes built in. OK.
Hi. Is there the notion of a historian at the Greengrass level? So if you're doing analytics that requires some past 1 second of data, can you do something like that?
No, you asked me a pretty difficult question. So in that sense is whatever you mean by historian, the typical answer from me is write a Lambda function for that. Because, of course, the reality is you could, in principle, do everything for yourself. So what I wanted to make clear in the beginning is we were not going after a dedicated specific use case. We wanted to have capability that whatever is your need, you could build it yourself, because now we don't put any restriction on the Lambdas. So if you have a local resource which can have significant enough compute that you can do certain things like in data analysis or machine learning, and you have enough storage capabilities, then of course you can use Greengrass as the runtime environment where you write the code in Lambda and then use the trigger mechanisms to put this all locally on the storage. But it's not coming specifically built in with that functionality. The functionality was, again, executing Lambda functions, whatever you put into the code, messaging between Lambda function, Greengrass core, and the local devices, big or small, state synchronization via device shadows, and the security element. So that are the 4 fundamental principles of, if you like, distribute compute, but then the application you would still have to write depending on your use case. There's more over here.
So my question is related to the edge. So within the edge, it's kind of thinking as a centralized system for the edge. But there are environments where you might have distributed systems within the edge itself. So how these devices will work each other, or they will be independently connected to the cloud? Because you might need a scenario where you want to talk within themselves rather than going through the cloud.
So very good. So again, a Greengrass group consists of multiple devices, many, hundreds of them. At launch now, we mandate that you have at least one device which you call the Greengrass core, which can execute this runtime environment and then the messaging. Then you can have multiple, hundreds of devices connected on a local network because the underlying infrastructure is managed via a pubsub subscription service. So you subscribe to a topic, so the different devices can now exchange messages, and then it can trigger action on this Greengrass core via Lambda function. If the question were, can I have multiple Greengrass cores work today in concerto, for example, for fallback mechanisms? The answer is no. That's the starting point. We started with one Greengrass core, and you can, of course, have other very powerful devices which could, in principle, run Greengrass core, acting like what we call a Greengrass-aware device. But we are, of course, now working with our customers, and typically always use customer use case to figure out what is the need. Is there a need that we build a Greengrass fallback mechanism? Because, again, this question that the gentleman had about local machine learning and what you can do there, you could, in principle, of course, write your own fallback mechanism just to have Lambda function saying is if this, fallback to that. But out of the box, it's, again, these 4 functionalities.
So just to be clear, if the question is, will Greengrass help you manage the communications between the devices?
The answer
that's
is
a
yes.
core functionality of
core functionality between the devices, subscription to the devices, being offline. So like you've seen the factory floor, you more or less can have the entire factory controlled, remove the internet connectivity, it still works. The question is, what if the Greengrass core device goes down? Then from today's perspective, if you don't build in additional fallback via your Lambda functions, then of course the system would go down. We don't control the local infrastructure or devices, that's customer controlled. Yes, please.
Yeah. So Lambda functions in the cloud have runtime restrictions and memory restrictions. Are the functions that you run inside Greengrass, do they have those same kinds of restrictions? How are you working with that?
I think the biggest restriction, so starting with Greengrass as general availability today, we currently only support Python 2.7. So if you ask, I want a complete different type of language environment, today that's not available. You could, of course, build it yourself. You're working on something like bring your own runtime and extend it to other languages. The biggest restriction in Greengrass is the amount of compute and storage you have on your local device, because we don't control that. So if you have a tiny little device with a little bit of storage beyond 128 megabytes, we can't control what type of Lambda function you put into that. So your main restriction will be the capabilities of the local device, because we can't predict this and foresee this. So if you were using and trying to say, let's say, I don't know, hundreds of megabytes of code and try to press this into a device which can't handle it, of course it will fail. So the biggest restriction in the local Greengrass environment is the capabilities of your device. And of course here we require a little bit of intelligence of our customers as well, because it's their devices and they typically know upfront what type of capabilities they have. One more question on this side.
Currently, AWS Lambda runs up to 1,000 concurrent instances, and each instance can run for up to 5 minutes. Let's say I had a local device that's running Greengrass, and it had, I don't know, I'll make up a number, 100 cores. Does all of the core scheduling, the Lambda scheduling, happen as part of Greengrass?
No, it doesn't. Again, in that sense, we don't have a distributed compute infrastructure management foreseen. We just, in reality, and that's why we can't work with Linux and Ubuntu Linux, because we just have the underlying operating system managing the infrastructure, so we don't take advantage of multiple cores for Lambda execution at start. It's just what your operating system delivers, and then you just have it as like a runtime environment, and that typically runs.
I think we have time for one more question. Anyone else?
Can you run Lambda? You will have actually the ability of have very long Lambda functions running. So you can have them more as continuously running, because we don't have these restrictions. It's at the end of the day, it is your infrastructure, it is your devices. You decide what you want to do and run on your devices. So you can have a Lambda function that runs forever.
Great. Well, thank you, everyone.
Thank you. And by the way, we have a lot of experts for Greengrass in the room. We have the snowball edge there. If you have more questions to the engineers, feel free to talk to them. Absolutely. Thank you very much.
Thank you.